Okay, here are the solutions to the letter problems for 8-3. First of all, we have A. We're given a diameter of 22. Because it's a sphere, we know we want to use a radius, so we drop it in half to 11. And our formula tells us to go 4 divided by 3 times pi times the radius of 11 cubed. Remember, we're cubing for spheres. And that will give you an answer of 5,575.3 cubic centimeters. For letter B, we have a radius of 5. Very easy. We plug 5 into our formula right here. 4 divided by 3 times pi times 5 cubed. And our answer is 523.6. And in this case, we have cubic millimeters. Letter C. We have a radius of 1.2. Our formula says 4 divided by 3 times pi times 1.2. Remember, you can use the caret key to raise that to the third power. And we get an answer of 7.2 cubic inches. Letter D. We have a diameter of 6. So we're going to use the radius of 3, 1/2 the diameter. And they also give us a rate. The snowball is melting at the rate of 1.8 cubic centimeters per minute. So we can calculate the volume of the sphere at 4 divided by 3 times pi times the radius of 3 cubed. Once we have that number, if you think about it, if it is melting 1.8 cubic centimeters per minute, we can divide by that number in order to figure out how many minutes it would take. 62.8 minutes. Letter E. Diameter is 2, makes the radius 1. Remember, this is a hemisphere problem, so we're going to divide by 2 and we're done because we only want half of that spherical volume. So we have 4 divided by 3 times pi times 1 cubed. You can pretty much skip that because it's still 1. It's the identity property of multiplication. And then divide by 2. And we get a final answer of 2.1 cubic centimeters. So if you had 4.2 or something thereabouts, remember what you forgot to do was the fact that this is a hemisphere we're looking for the volume for, so we have to cut it in half, divide by 2. Letter F, we have a radius of 9, another hemisphere problem. 4 divided by 3 times pi times the radius of 9 cubed, and then divide by 2 to get just half that sphere, and we have 1,526.8 cubic meters. Okay, this is 8-3, guided practice. First problem, we're again doing volume of a sphere, so our formula is 4 over 3, or 4 divided by 3, times pi times the radius cubed. Don't forget to cube. That's one of the mistakes that will often happen with sphere problems. And in this case, we have a radius of 10, so it's a matter of putting all the digits into the calculator and doing the calculation, and you should get 4,188.8 cubic feet. Problem number 2 has a radius of 6.5. So in this case, I wrote it as 4 over 3, so you remember it's just a matter of 4 divided by 3 times pi times 6.5, and you could use your caret key to raise it to the third power, put it all in the calculator in one string, and you get 1,150.3 kilometers cubed. Another thing to always make sure you're paying attention to with these problems is make sure you get your unit down right away, and volume is always going to be cubic units. Problem number 3. This is a word problem, and there's 2 steps to this problem. First of all, we have to calculate the volume of the balloon. The volume of the balloon is fairly straightforward. It has a radius of 3, so it's 4 divided by 3 times pi, that first string that's always going to be the same for volume of a sphere. And our radius is 3 raised to the third power, so we get 113.1. There's actually more digits in there. You're not going to round this. Remember, you only round once. And because we can put 200 cubic inches of air per minute into the balloon, in order to figure out how long it's going to take, we would take our volume that we have and divide it by the rate, or divide it by the 200 cubic inches per minute. And as you can, if you just think about it, 113 is a little more than half of how much we can do in a minute, so it should take us a little more than half a minute, and indeed it works out to be 0.6 minutes. Problem number 4, now here they throw a curveball at you. They do what they're going to do quite often with these problems. They give you a diameter in spite of the fact that you need a radius. So really simply, first thing you should do in your book is draw a line through the diameter of 16 and put r equals 8 there, and then use your formula. The second thing that you should also do is right away write down that you're going to divide by 2. The reason you're dividing by 2 is simple. We are going to calculate the volume of the sphere, which is this part of the problem right here, but we have to divide it by 2 to get just the hemisphere, 1/2 of the sphere. So it's 4 divided by 3 times pi times the radius of 8 cubed divided by 2 to account for hemisphere, and you get 1072.3 cubic inches. Problem number 4 is similar. Again, they give you a diameter. You cut it in half and cube it. And they also ask again for a hemisphere. So it's 4, volume equals 4 divided by 3 times pi times 7.5 cubed divided by 2. And you get 883.6 millimeters cubed in this case. Problem number 6 is an interesting problem. They basically say if I took a sphere and I took 2/3 of that, 2/3 of the cylindrical volume, would it equal that of the sphere? Well, in the case of the sphere, it would be 4/3 times pi times the radius cubed. In this case, they say if I used a cylinder with a radius of r, so that's right here, and a height of 2r. So I drew it on the diagram here. So our volume becomes pi times radius squared, which is the area of the base, times the height, which is 2r. Now if I rewrite this, instead of pi times r squared times 2 times r, I can go 2 times the pi, combine the r squared and the r into r cubed, and now it's in a form that's more like this one here. But now they ask for 2/3 of, and one way to think about anytime you hear of in math, for example, if I had 4 packs of 5 gumballs, let's say, how many would I have? Well, it's a multiplication problem. 4 times 5. Whenever you hear of, it's a multiplication problem. So 2/3 of, I have to take and multiply this equation by 2/3. So if I multiply that by 2/3, it would be 2 times 2 is 4/3. So that's where the 4/3 came from here. And then I still am multiplying by pi. I'm still multiplying by r cubed. So what we're comparing here, as they're asking you, is this the same as this? And indeed the answer is yes. It would be the same if we had a sphere and we had 2/3 of the volume of a corresponding cylinder.